So my name is Steve Greenberg. I'm actually one of the Cloud.gov operators. And so today we want to give you a quick introduction to the Cloud Foundry platform within Cloud.gov. A little bit about me. I'm a longtime developer, so I've actually been doing this for a little over 20 years now. Turned kind of platform operator. I've got a long history with Cloud Foundry and the Cloud Foundry project. I've actually been working with Cloud Foundry since about March of 2012. I'm a regular contributor and a Cloud Foundry ambassador. We're going to talk a little bit about Cloud.gov and what it is today, but I'm not going to show you a whole bunch of slides. The goal here is actually to give you a little bit of taste of what it looks like to use the Cloud.gov platform as a developer. And so a lot of this is actually just going to be us deploying applications, creating databases, and doing some fun things with the platform. If you do have questions as we go, we've only planned for roughly about 30-35 minutes or so of a demonstration to allow plenty of time for questions at the end. Please feel free to post questions in the chat, and we'll try to get to them after we get through this. Sound good? All right, so caveat, Cloud.gov is pretty big. Its goal is basically to allow government agencies and organizations to develop and deploy and manage applications easily. A big component of that is a technology called Cloud Foundry. And that's really what we're going to talk about today. So if you're not familiar, Cloud Foundry is an open source product and project. It is governed by an open source foundation. You'll find it in roughly half of the Fortune 500 companies, in large organizations like Home Depot, Daimler Chrysler, Allstate, and a whole host of other companies as well. And so we're going to look at what it actually looks like to deploy and manage applications throughout their lifecycle on Cloud Foundry. There's a lot to Cloud.gov, so I'd encourage you to please go to our website. It is just Cloud.gov. To see some of the other features and functions. There's also a lot to Cloud Foundry. So I'm just going to go through the basics today, but hopefully that gives you a little bit of idea of what's actually going on. So I'm going to go ahead and share my screen and we'll get started. Okay. Can you see my screen? Kara, can you give me a thumbs up? Yep. Okay, great. Let me get rid of this real quick. All right. So I'm sitting here at a terminal window, and a lot of this is actually going to be in a terminal window because as a developer, usually the way that you interact with Cloud Foundry is through this thing called the CLI, or command line interface. It is this thing called CF, and I can type CF, and it allows me to basically interact with any Cloud Foundry that's out there. Now in our case, we want to interact with Cloud.gov, but it's important to know what the CLI is. It is basically a tool, again, to interact and manage users. It's a tool to manage the lifecycle of your applications and interact with any Cloud Foundry, not just Cloud.gov. So there's a whole bunch of different Cloud Foundry distributions that are out there, and everything that we're going through today actually applies to all of those distributions as well. One of the great things about this CLI, if you do choose to, let's say, follow along or do this after the fact yourself or start using Cloud.gov, is that it is self-documenting. And so you can do things like type CF-H and see the list of most frequently used commands. You can do the things like type CF-help-A and see all of the commands, and there's quite a few. Or you can just do CF any command --help, and it tells you exactly how to use that particular command. Not super important for us today, though, because I know what I'm doing. Let's cut to the chase and actually deploy an application. Okay. So I've got an application actually here on my laptop. It is just a simple Go application. It would run locally. There's nothing special about the code here. It's just an application that we built for training, just to kind of demonstrate the capabilities of the platform. There's nothing tying this particularly to Cloud Foundry except this one file called manifest.yaml that you can actually see here. What this file is just a few directives for telling the CLI to tell Cloud.gov what you want to do with this application. So in our case, we're just going to give it a name so we can refer to it in Cloud.gov. we want to basically tell it to create an instance, allocate 32 megs of memory and 128 megs of disk. Let me back up real quick, because one thing I forgot to tell you is that I'm actually already logged into Cloud.gov. If you're using a Cloud Foundry platform, you can point your CLI and authenticate to any Cloud Foundry platform. I've already authenticated through the GSA identity provider. If you're bringing your agency over to Cloud.gov and you have your own identity provider, chances are we can integrate that and give you a single sign-on experience there. So essentially at this point, I'm ready to go. And so if I want an application running on Cloud.gov, it's pretty simple. I type cf push. When I type cf push, what's happening is that command line interface is essentially reading that manifest file, and you can see that it's doing some work up here. And it's taking that actual Go application and sending it up to Cloud.gov and saying, can you please start my application and run it and give it these resources. That's really it. That process, it's going to take, a little bit less than a minute or so. And the output of this is I'll have a running application on Cloud.gov. And all I really had to do was give it a few directives around things like the name, the amount of memory, the amount of disk, and so on and so forth. And now if I grab this route, I can jump over to a browser here, and I've got a running application available on Cloud.gov. That's it. As a developer, let's take a look at kind of what actually happened here. So when I go back through this, again, I had my manifest file that specified a little bit of information about my application, including the route that I wanted my application to be available on. So this is just a web app. So of course I need a route, right? I need to be able to actually access it in a browser. You might think of this as DNS. We have a default domain, app.cloud.gov, that we can use for any application. If your agency has your own, you can bring your own domains to cloud.gov as well. But once we reserve that route, we then basically took that application code from my laptop and uploaded it, to cloud.gov. It then took that application and looked at it and used this thing called a build pack to send it through this process of essentially creating a layered container image of my application that can be run in any container environment. So if you're familiar with containers, you may have heard of Docker, you may have heard of Kubernetes. These are containerization technologies that have been around for a few years. Cloud Foundry has actually been containerizing and running applications from its inception. So we've actually been using containers long before Docker existed. Once we construct that container image, we can actually run it. And once we run it, that application then becomes available again on this route in a browser, and anybody can access it. So if you've been in this game a long time, this is actually a kind of a big deal, right? It's a big difference, let's say, from deploying an application to Amazon EC2 or Google Compute, right? Where you would have to go provision a VM, install some software on it, like maybe the Go runtime. Maybe you'd have to configure networking or security groups or disk or storage, and a whole host of other things just to get your application running. And then you got to go, reach out to your DNS folks and actually get DNS set up. All we had to do here was type cf push. And that's really kind of the whole point of Cloud Foundry and Cloud.gov from a developer perspective. We just want you to focus on writing your application. Bring us your application and we'll run it for you. And we want to make that process as easy as possible. And so that's what we've done here. So we've got a real simple app now, and it's running. But most applications need services, right? They need something else to interact with. And maybe that's like a database service. Maybe it's a message queue. Maybe it's a bunch of different services. Who really knows, right? I also want to be able to provision a database service and tell my app about it. So let's actually go back to the CLI here in the command line and do that. So let's assume that I want a MySQL database for my application. Now, back when I started, I would then have to go kind of procure some hardware, figure out how to install MySQL, configure it, and do a whole host of other things, right? In Cloud.gov and in Cloud Foundry, I can instead go to this place called the Marketplace. And I know this isn't formatting great just because my window's a little bit small, but the Marketplace shows me a whole host of services that are available to me to provision on demand. I don't have to open a ticket. I don't have to ask anybody's permission. I don't have to procure hardware. And I also don't have to know how to provision any of these things. So for me, I want MySQL. So let's just go look in a little bit more detail at our Amazon RDS or Relational Data Service services that are available to me. What I'm seeing in this list is all of the things from Amazon RDS that I'm allowed as a developer to provision on my own within Cloud.gov. Again, with no tickets, with not asking anybody. So in my case, I just want MySQL. So let's create a MySQL database. Well, in Cloud Foundry, that's pretty simple too. Once we know what service we want to create, in our case, it's an instance of Amazon RDS, we're going to create the shared MySQL plan. If you look at what this list is, these plans allow us as the operators to define some tiers, capabilities, and offerings within the same service that you can provision on demand. So in my case, I just need something small and simple and easy. And then I can give it a name. I'm going to call it First Push DB because it's related to my First Push app. And I'm going to hit enter. And wow, that was quick. So what actually happened? Let's look at CF services. I've actually got now a new MySQL database that's been provisioned according to this, essentially this plan that's available here, available. I didn't need to know how to install MySQL, how to configure MySQL, what compliance related checks needed to be in place for me to actually get an ATO to run my app with this instance of MySQL. I didn't need to know anything about that. All I needed to know was to go look in the marketplace and to run CF create service. And that's it. And so this is important because, look, a lot of people have experience with MySQL. They probably know how to, basically set one up. But what if it's something more complicated? What if it's a large MySQL cluster with, redundancy and failover built into it? Those are complicated. And if we burden every single developer with that amount of knowledge, then we're slowing those developers down. And that's not what we want to do. We want to give you the tools and the capabilities to do the job that you need to do as quickly as possible and abstract away all of the other complexities so that you can focus on building your applications. Okay? So now we've actually got a database. Our application doesn't know about that database though. That's simple fix. There's another command called bind service. And so what CF bind service is going to do is basically take the name of our application, take the name of our service instance, and tell them about each other. So let's do a CF bind service. We'll start with first push. We'll go first push DB. And we hit enter. And that happens fairly quickly too. I'm also just really quickly going to restart the app and then I'll explain what's happening. So when I did CF bind service, again, the Cloud Foundry component reached out to the provisioner and basically said, hey, I need some credentials now. I need unique credentials for an application so that it can use this database. This is all happening, this provisioning and binding and credential management is all happening through a standardized component called a service broker. A service broker is nothing more than essentially an API that is actually supported by just about every major cloud platform today. So things like Amazon, Azure, GCP, Kubernetes, Cloud Foundry, they all support this standard. And that standard basically allows us to make calls like CF bind service to go generate a unique set of credentials for our application now to use to talk to that database. Okay, so we do that, we go back to our browser, we refresh, and we can see that now our application knows about this database. And again, as a developer, I don't need to know how do I actually manage these credentials. Like, how do I generate them? And then how do I tell my app about them? Those are big challenges in most development organizations. If you've done this long enough, you probably had a really big spreadsheet at one point that said, here's my development database, here's my staging database, here's my production database. Not very secure, not very easy to manage. Instead, I can do CF bind service and essentially restart my app. And my app can pick up that change. Now, the way that this is all happening is essentially because we built our Go app to look to environment variables for our configuration. So if you're building cloud native apps, you've probably heard of this notion of 12-factor app best practices. And one of those basically says, inject your configuration through environment variables. And that's all we're doing here. There is no magic. So Cloud Foundry is reaching out to our AWS RDS service broker. It's saying, please generate some credentials for me. It's getting those credentials back, and it's setting those as an environment variable that our application can then parse and use. That means that we didn't have to change any of our application code. It means that we didn't even have to see our credentials. I mean, there are ways to do that, but we're not going to get into that here. All we had to do was ask for them, and we can get them back. And that's why we had to restart our app, so it would pick up that environment variable change. But now our application actually knows about that database. Okay, and we can see that application and that service actually being bound. All right, sorry, I meant to run CF services. There we go. Great. So we can now see that our database is bound to our app. We can also, again, see that in the user, in our web browser here. Again, this is just a simple training app that we've created that allows us to see it. Okay. I do see that there's some questions coming in the chat. I'll answer those after we go through a little bit more of this. All right, so a little bit of convention. Inject your configuration through the environment goes a very, very long way. So we now have a running application. We've provisioned a database. We've told our application about it through some unique credentials. As our application is talking to that database, it's not going through the broker. There's no slowdown there. It's doing it just like any other database connection in any other language would be happening. So nothing to worry about there. But if you look at our application right now, we only have one instance running, and that's usually not a good idea. Everything in the cloud, everything in technology at some point is going to get restarted. It's going to crash. It's going to get recreated. Maybe as operators, we're updating the platform underneath. Who knows? But we should have at least 2 instances running. So let's go ahead and actually scale our application. So we can run CF scale, the name of our application, and we can ask Cloud Foundry or Cloud.gov to run 2 instances of our application instead of 1. And I hit enter, and almost immediately it comes back and says, okay, great, no problem. Run CF app, the name of my application. I can see now that I have 2 application instances running. This is a very quick process. It's very quick actually to scale up horizontally in Cloud Foundry and in Cloud.gov. Because early on in that push command, if you think back to a few minutes ago, we created that layered container image. That container image was cached. So when we said, hey, we need another instance, all Cloud Foundry had to do was go fetch that container image and run it in a new container. When that container actually passed a health check, then Cloud Foundry automatically updated its routing table. And I can see that by going back to my application here. And you'll notice that there's an app instance index as well as an app instance GUID. If I keep refreshing this page, what you'll see is that Cloud Foundry is actually load balancing across those application instances automatically for me. So in my case, I said, give me 2 instances. I could have just as easily said 10 or 20 or 30, right? And as those new instances came online, and as those new instances passed their health check, Cloud Foundry was automatically updating its internal route tables and starting to send traffic to those new instances. So again, take a step back now from Cloud Foundry and think about what would happen or what would have to happen if you were doing this in another infrastructure as a service provider like Amazon EC2. I'd have to spin a new VM. I'd have to do the same kind of configuration that I did when I first deployed my app. But in this case, I also now have to deploy a load balancer. And I have to tell that load balancer about all of my instances so that it can start doing the same work that Cloud Foundry is just doing for me. And again, I could have said CF scale 10, I could have said CF scale 20, wouldn't really matter. But it's able to very, very quickly create new instances of my application and then start sending traffic when those instances become available. So I can keep refreshing and you'll see that I'm getting load balanced across those instances. All right, so that's good. I feel better about that, right? Because now I actually have two instances running. So if one of those instances crashes, I should be okay, right? Well, let's actually see what happens when bad things happen. What we can actually do is programmatically kill one of these instances. And to actually demonstrate this, I'm going to just pull up two different terminal windows just to make it a little bit easier. So in this bottom window here where it says CF logs, I'm actually going to tail the logs to the application in near real time. So I've got two instances. Cloud Foundry is aggregating all of those logs and sending them to this output stream for me as I access the app. So if I start tailing the logs and I click back over here and I refresh a few times, you'll see that I'm actually getting logs for both instances. The reason I'm doing this is so that I can see when that instance crashes, okay? On the top here, I can run a command called CF app, and that'll again show me how many instances I have running and kind of the state of those instances. I'm just using a standard Unix program called watch to actually rerun that CF app command about every second, okay? So let's go back to a browser. Let's open a tab. We'll say first push, and we're going to tack on /kill. Now, let me pause and give you a little disclaimer here. Don't build applications with a kill endpoint, okay? This is solely for the purpose of demonstration. We did actually put this in there, and all it's going to do essentially is issue a system.exit and basically programmatically kill those instances. I have to make that disclaimer because I've actually seen this show up in other applications. So if you do go look at the source code for this, please don't copy that. Not a good practice, not necessary. Okay. When I hit enter here, what's going to happen? Well, that instance again is going to have a system.exit. It's going to crash. I'm going to very quickly switch back over to the two terminal windows and we'll see what happens in those two windows. And then I'll do it again and show you what happens from a user perspective. So first, that request failed. Not surprising. You can actually see that that container already exited here. You can see that very, very quickly, Cloud Foundry actually determined that that application instance had crashed, okay? Up here in, back down here in the log window, what happened right after it determined it crashed is it just created a new one. So it determined that you asked for two instances, or I asked for two instances to be running. There's only one running. There's a problem. Let's fix the problem. And it started to take action. On average, it'll start to take action within about 1 to 3 seconds. I didn't have to do anything specific for my application. All I had to do was run it in Cloud.gov on Cloud Foundry, okay? What happened up here is almost nothing, actually. And you probably didn't even see it. At some point, one of these instances would have been reported as crashed, and then a new instance would have been reported as starting. But the same process as when I scaled happened. We took that cached container image, we started a new instance. When that instance was available, we started sending traffic to it. And I didn't have to do anything. So let's go back and see what happens from a user perspective. So I've got my app running in this tab, right? I've got my kill endpoint here. I'm not going to hit enter yet, but I can again refresh and see that I'm being load balanced across my two instances. Now, let me kill an instance and jump back here and keep refreshing. And let's see what happens. Oops, let me get rid of this little bar up here. All right. So I hit enter, I go back here, and what you'll see is as I keep hitting refresh, I keep hitting only instance 1. And I'll keep hitting refresh for a few more seconds. And what you see is that when that new instance comes online, it just popped up that I'm now being load balanced across instance 1 and instance 0. So from a user perspective, nothing really happened, right? If I didn't actually expose this app instance index and the app instance GUID here, nothing would have happened. I just would have continued to access this application, this site, whatever it is, and I would have been routed to the healthy instances. That's a really, really big deal if you stop and think about it. And this is actually only one of the resiliency capabilities built into the Cloud Foundry platform. But back in my day, I actually did have to carry a pager at times, and that kind of stinks, right? Because apps would go down and somebody would actually have to go fix it. In this case, Cloud Foundry is just sitting there watching. And it's got a picture of the desired state of the world. Basically, I need 2 instances of this app running. And it keeps checking against the actual state of the world. In this case, I killed one. So there's only 1 instance running. And it knows how to take action to correct that. And so that's a big deal from a user perspective. That's a big deal from a developer perspective, but also just from running your apps. It's not just about building a really good, cool app, but you also want to keep it running. You want to serve a lot of customers. A lot of you might actually have kind of very volatile kind of traffic loads. The ability to really quickly scale up and then scale back down to meet those demands is trivially easy in Cloud Foundry and in Cloud.gov. The ability to keep your applications running so that your users can get the data that they need or have the interactions that they need is trivially easy. And again, there's nothing special about this application. It's just a regular Go app. Cloud.gov would treat it the same if it was Java or Ruby or a whole host of other languages. It doesn't really matter. You get all of the same capabilities and all of the same functionality, regardless of the language that you're writing. And so as a developer or as an organization that supports developers, if you want them focused on doing things that actually help your customers, your business, whatever it might be, Cloud.gov is a great platform for that. So we have now deployed an application. We've provisioned a MySQL database. We've generated unique credentials for that database. We've told our application about those credentials. We've scaled our application, and we've looked at what actually happens when that application crashes and dies. That's an awful lot to do in roughly 30 minutes with really only like 4 or 5 commands. And that's really what we wanted to show you today. The last thing I want to do is just clean up. Because in the cloud world, it's also pretty easy to let your mess sprawl. In Cloud.gov and in Cloud Foundry, it's really actually easy for us to get rid of everything we just did. I can run cfd or cfdelete on my app. And my app is now gone. As soon as this returns, there we go. And I can also delete my database using cfdelete service. Whoops, sorry. So for organizations that also want to efficiently use resources and not have a huge amount of sprawl or a huge cloud bill at the end of the day, this is also pretty darn important. So in about 30 minutes, that is the basic functionality of using Cloud Foundry as a developer within the Cloud.gov platform. There are a number of other links if you want to kind of do some of this on your own. They are on the Digital.gov event page. You can go look and you can get a sandbox on Cloud.gov and try this out for yourself. There's more information certainly on our webpage about all of the other functions and features that you can see that Cloud.gov provides. There's information on Cloud Foundry as well. And we encourage you to actually just go try it and take a look. So that's what I had. Why don't we answer some questions? I was going to say, Steve, we have a number of questions in the chat, so I'm just going to kind of start
as they came in, the order that they came in. So the first one is, how do we know what the memory parameters should be?
So the memory parameters, you'll really have to just figure out based on the language that you're using. So in our case, we're just using Golang. And so Go has a fairly small footprint. If you were using Java, you'd have a lot more memory. That's just part of the development process, quite honestly, on Cloud.gov. And so you'll go through and push an application and see what happens. And you should be able to actually look at it and monitor what's happening within that application. We do actually have a user interface that'll show you metrics on what your application is actually consuming. And so it's part of the development process. It's also going to be tied specifically to that language. The one thing to keep in mind is the amount of memory that you're actually allocating is to the container, not to your application. So there is a little bit of a difference there, but it's just part of normal development. You know, you load test your apps and you figure out what the right sweet spot is.
The next question, is there an ability to get code from a source code repo like Git, basically a GitOps approach?
Yeah, so that's a great question. So there is not a built-in functionality in Cloud Foundry that fetches code from Git, but it's pretty trivially easy to hook up any CI/CD system to Cloud Foundry. So Jenkins certainly supports that. Circle CI, my favorite, Concourse certainly supports that. And so, you know, typically in pipelines that we have, we just have Concourse essentially, you know, pick up those changes from Git and do exactly what I showed you. Concourse can do a CF push.
Okay. Next question is there a web UI?
There is a web UI. Great question. So if you go to dashboard.fr.cloud, whoops, sorry. Dashboard, not beta. .fr.cloud.gov. There is a dashboard, and so if you get your account and you log in, you'll be able to actually see the dashboard as well, and you can see your applications, you can see some of the monitoring tools, and it's prompting me to log in, so I'm not going to do that right now. But you can see some of the metrics that are actually happening as well.
All right. What is the difference between a restart and a restage?
So some folks have actually used Cloud Foundry, so that's a good question. So I kind of skipped over this, and for anybody that is not familiar with Cloud Foundry, this might be a little bit deeper into what's actually happening. But when I did that push, I had my app code uploaded to Cloud.gov, and the first thing that Cloud Foundry really did with that app code is it sent it through this process called staging. And staging uses a component called a build pack, which has now become kind of another open standard, but that's the thing that's really building that layered image, that container image. In Cloud Foundry terms, we call that container image a droplet. And that droplet is essentially that image. So when I do a restage, I'm essentially sending it to the build pack again to recreate a new layered image of my app code. When I'm doing a restart, all I'm doing is taking whatever the existing layered image is and starting a new container. So again, that's probably far deeper than you know, anybody that hasn't used Cloud Foundry needs to worry about, but they are a little bit different. So if you think that layered image or that droplet can change, you need to do a restage. Otherwise, you can just do a restart.
Okay. Next question, does running 2 instances automatically put them in high availability?
Yeah, so that's a great question too. So ultimately, having more than one instance is a good thing, right? There's actually other capabilities built into this platform. And so in Cloud.gov, we're actually running in multiple availability zones in Amazon's GovCloud. So because we're running in multiple availability zones, when I actually said I want 2 instances running, Cloud Foundry knows that there's multiple availability zones, and it tries to ensure that there's an instance running in each of those availability zones. And so it is actually putting them into a high availability mode and distributing those instances across those availability zones. And so that's important because if Amazon GovCloud had a catastrophic failure or one of those availability zones became unavailable, the platform keeps running and your customers probably don't see anything.
Okay. All right, you've addressed the benefit of Cloud.gov and Cloud Foundry compared to simply using an IaaS, an infrastructure as a service like EC2. Can you
Yep.
please compare to AWS platform and container as a service offerings like Elastic Beanstalk, ECS, Fargate, EKS?
Yes. So another great question, and also probably a little bit more technical question as well. The biggest difference, let's just take Kubernetes in general as an example of a container as a service offering, right? The biggest difference, let's say, between Cloud Foundry, Cloud.gov, and Kubernetes is in Kubernetes, you're really bringing your own container. So you're responsible for that layered image. Now, in some organizations, that's not a big deal, but you think about the world that we play in with lots of compliance. Simple question. How many versions of Ruby are you running in production? And how many versions of Ruby are vulnerable? That's a really hard question to answer using strictly a container as a service offering. You actually have to build a whole bunch of infrastructure to track those types of dependencies and to make sure that those updates are actually flowing through when vulnerabilities are discovered. When I'm using Cloud.gov, I'm not responsible for the container. As an operator, I'm actually responsible for providing you build packs that build compliant and appropriate containers with the right patches and security applied. And that's a big, big difference. So some people may actually remember, I think it's probably about 3-4 years ago, something like that. There was a really big vulnerability called Heartbleed that was actually out and really affected a cryptographic library that essentially made it affect almost every single computer that was out there, as well as a lot of runtimes and cryptography libraries like SSH. If you were just using a container as a service offering, somebody's responsible for patching Kubernetes. I don't know who that is, but that's true anywhere, right? So EKS. But how do you know which containers actually had that vulnerability? And when you discover which containers actually were vulnerable to Heartbleed, how did you patch it? In Cloud.gov, as operators, we uploaded a new build pack, and we basically told our users, run CF restage. And that's it. We fixed Heartbleed, and it's over. We know which containers are still vulnerable because you haven't restaged. If you restage, you're fixed, and everything is good. So there is a big difference in terms of the abstraction and really where the responsibility lies in a container as a service pure offering, as opposed to something like Cloud.gov. And I think it's even more applicable in highly regulated environments like ours.
Okay. I would like to know your method of restoring an existing database to the one created in Cloud.gov.
Sure. So you can bring your own databases. I showed you the marketplace. You can bring your own stuff to Cloud.gov if you want. If you wanted, let's say, to export the data from your existing MySQL and let's say import it into an instance created in Cloud.gov, you can do that as well. There's a ability for you to actually create what's called a service key, which is credentials for you to connect to those data stores. And so you can basically use the same tools, if it's MySQL, MySQL dump or Postgres dump or whatever, and move the data and actually import it. But you can also just bring your own databases and point your applications running in Cloud.gov at your existing databases, provided that your agency allows you to. There's no firewall issues or anything like that.
All right. What are the options for app logging integration for monitoring and/or debugging purposes? Are there any PCF tiles available supporting GIS software like Esri Arc Server software, for example?
Sure. So two different questions. So the options for app logging. So first, you can do what I did and basically tail the logs. You can also view recent logs through the CLI. Built into Cloud.gov, we actually have the the ELK stack, so Elasticsearch, Logstash, and Kibana. So we have that built in, and that's available to users. So you can log into that and basically see your logs in those tools, and your logs will basically just show up. If your agency has your own log drain service or log analysis tool like Splunk, you can also hook up those tools to your applications running in Cloud.gov through a notion of a log drain. So really the options are there. We give you some pretty significant and robust out-of-the-box solutions. But we also have a lot of customers that actually need to have their logs going into an agency-specific drain, and it's pretty trivially easy to set those up as well. The second question about PCF tiles. So somebody else who's familiar with Cloud Foundry, PCF refers to Pivotal's distribution of Cloud Foundry. For Cloud.gov, we are actually running open source Cloud Foundry. We are not running Pivotal's distribution. So we don't have any tiles. Are there services for, let's see, any GIS software? I'm not sure, but potentially. And if there's not, and you wanted to implement your own service broker, you can implement your own service broker as well. Not a big deal, pretty simple to actually do in a variety of different languages. But if you also had any kind of GIS data sources available, there is a notion of a user provided service that you can make available inside of Cloud.gov. So.
All right. When you run two instances, are they using the same database?
Yes, they are. So in our case, the way that we set this up is we wanted to scale elastically horizontally out. And so what that means is we can run lots of different instances or compute nodes, but they're really effectively the same application. So they are all sharing the same database. If you had two different applications, you can certainly create different database instances if you want.
Okay. And any thoughts or plans for deploying Cloud.gov in AWS GovCloud East?
Yes. So right now, Cloud.gov is running in AWS GovCloud West. We have been talking internally about how to make more deployments of Cloud.gov in different regions. Maybe that's for scale reasons, maybe that's for redundancy reasons. We've been talking about it. I don't know that it is anywhere on our schedule or will be anytime soon, but it is certainly a capability that we can do if necessary.
All right, looks like another question just popped in.
Yep.
Are there any recent TIC related developments for GovCloud or Cloud.gov, especially regarding TIC 3.0?
So I will be completely honest and tell you that I'm a contractor and I don't know what TIC is. So if you could explain that. Do you know, Kara?
I do not know.
Okay.
Trusted internet connections.
Trusted internet connections. And so is that, yeah, okay.
We can look up, we can follow up and look into this further.
Yeah, that's not something I know off the top of my head. I'm still relatively new on the team here, so, but it's certainly something we can get back to you on. Oh, Eddie just posted a link as well. Okay, so any other questions, any other things that we can answer?
Is there a published roadmap for Cloud.gov? There is not a published roadmap. We do have a roadmap. It is not published, but we do have one. It is always evolving, as roadmaps are. They are living, breathing documents. But we do have a roadmap for it.
Okay.
Are there other questions? All right, looks like the Digital.gov team is gonna just jump in here to close us out.
Yeah, so real quick, just a reminder, you can go back to the Digital.gov event page and there are some links there. So please take a look at that and feel free to, give us a shot, sign up for a sandbox account and check it out for yourself. We are doing more tech talks as well for different audiences on a variety of topics. So also check the Digital.gov calendar and you'll see more. Appreciate everybody taking the time. It looks like actually there is another question. Is there a difference between using a manifest YAML versus CF push parameters? Ultimately, no. I could have certainly done the CF push and actually specified the memory and the number of instances on the command line. I choose to do that in a manifest because it's repeatable. And so typically we gravitate towards using manifests so that anytime we do a push, it's exactly the same. But functionally, it is the same thing. So no problem there. And it looks like Ethan asked, when is the next webinar and what is it about?
So the next webinar is happening in April. In fact, I have the date right here. And it's actually going to be Cloud.gov for product managers. So that's going to take place on April 22nd. So it's targeted at product managers or people who play product manager-like roles, but talking about Cloud.gov with a focus on PMs. And Steve, I think there was a question about Linux. We might have accidentally skipped over that one.
So how does Cloud.gov fit with Windows versus Linux apps? We have a lot of Windows apps. So this is, there's two parts to the answer here. So one is some .NET workloads actually will run on Linux now in Linux containers. Not all. So if you have Windows apps that are written in .NET, there is a subset that you should be able to run on Cloud.gov right now. Not all will. There is also a capability within Cloud Foundry to run what we call Windows cells, which are basically running native Windows containers. We don't have that ability in Cloud.gov. We don't actually manage Windows cells currently. So it's not something that we could do today, but it is a possibility in that it is supported potentially in the Cloud Foundry project, but it's not something that we currently have. Doesn't necessarily preclude you though. You should definitely look because there is a pretty large subset of .NET apps that will run on Linux containers today. All right.
Are there any additional questions? I think I'll hand it back over to the Digital.gov team. I will also drop in the chat the email address for Cloud.gov. So if you do have follow-up questions, you have a way to contact us. So I'll hand it back over to the Digital.gov team.
Thanks, Kara. Thanks, Steve. That was awesome. We have also dropped a survey in the chat. I believe it's a little bit higher up, but Gabby, if you could just drop it again. If you guys wouldn't mind all of the attendees trying to fill it out, we also will send it out to your emails as well. And yeah, we're looking forward to the second event, Tech Talk, in April. So we will send everyone who is invited to this event and who attended also the invitation to that one once it is put up online. And thank you everyone for attending.
Thank you.
Thank you.